Hi there, this is Mr. Khan from 11 Plus and GCSE Coach. In this video, we're looking at sequences in terms of numbers and shapes. What are sequences? Sequences are a set of numbers or shapes that follow a distinct pattern. You can see sequences in nature as well as in numbers. So here's an example: 5, 10, 15, 20, 25, 30. This is a sequence of numbers that goes up in fives, starting from 5. um, Here's a sequence of squares that make up a shape. So you can have sequences in many forms. Here's an example of sequences in nature. You'll see in many places where the object in nature actually follows a sequence of some sort. Flowers is a very common example, as well as many other objects like or things like butterflies, for example, and shapes in landscapes and all sorts of things. You can actually observe sequences in nature in many different ways. Um, we're dealing with specifically sequences using numbers and maybe some shapes a bit later on. So what are the components of a sequence? Each number in a sequence is called a term. So for example, in this sequence we have 1, 3, 5, 7, and 9, and the sequence goes on. However, the first term will be 1, the second term will be 3, the third term will be 5, and so on. So each specific number in a sequence is known as a term, and depending on where it is, the position of that number will determine the term it is. So some sequences follow a pattern that you already know, you can recognize them. So here's an example of a sequence of numbers, which are all square numbers. So you need to be able to look at a sequence, see is there like a very obvious answer. In this case, for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So this is a sequence of square numbers going up in order. Here's another example of sequence of numbers which are multiples of 5, but they're going down in this case, starting with 25. So 25, 20, 15, 10, and the next one will be 5, and so on. Here's another example of a sequence, prime numbers. So you need to know what prime numbers are. If you haven't seen that video on prime numbers, please go and watch the video on prime numbers. So this is a sequence of prime numbers going up in order, starting with 2, 3, 5, 7, and 11, and so on. So hopefully you understand what sequences are and what each term in a sequence is, and sometimes it's very obvious to recognize a pattern in a sequence. Um, Sometimes you actually have to work out what the next term will be. You have to identify the pattern first. Once you know a pattern, you can work out what the next term is. For example, in the sequence 2, 4, 6, and 8, they're all even numbers. They're going up in order. So you know the next number will be, so from 2 to 4 you add 2, from 4 to 6 you add 2, from 6 to 8 you add 2. So you'll add 2 more from to 8 to get to the next number, which is 10. How would you find the seventh number in this sequence? So in this case, because you know the pattern is to add 2, you simply carry on the pattern. So we know 2, 4, 6, and 8 are the first 4 terms given. I know the pattern from going from 2 to 4 was to add 2, from 4 to 6 is also to add 2, from 6 to 8 is also to add 2. So I simply keep on adding 2 in each case. So if I add 2 to that, I'll get 10. So which term is 10? So we know this is my first term, that's my second term, that's my third term, that's my fourth term, that's my fifth term. So I need the sixth and the seventh, because the question is just the seventh term. So I need to find the fifth and the sixth first, or sixth and the seventh before I can get to the seventh. From 10 to the sixth term, I have to add 2 more. I'll get 12 as the sixth term. And to get to the seventh term, finally, I simply add 2 more, and that will give me 14. So the seventh term of this sequence is actually 14. Um, so moving on, here are some practice questions for you to attempt. Pause the video and have a go at these questions and see if you get them right after you finished. So hopefully you've had a go at these questions. So the best practice is to find the common difference and go from 10 to 13. Write down, draw this arrow from going from the first number to the second number and see what the difference is. From 10 to 13 you add 3, 13 to 16 you add 3 again, and 16 to 19 you add 3 again. It's actually quite important you do that, because some sequences will seemingly they will see you will think that it's going up in equal numbers. However, some sequences do change, and I've got an example of that later on in this video. So anyway, so the next number, obviously I'll have to add 3 to 19. So I'll get 20, 21, 22. That's my next number. And then I add 3 more to get to the number after that. And that will give me 25. So these are the next 2 numbers in this sequence. So next sequence, I'm going from 35 to 32. So clearly the number is going down. So I have to subtract this time. So I'm subtracting 3. So I have to subtract again. I subtract 3. And again, I must be subtracting 3. As I said earlier, please do all of the differences from the numbers that are given to you, because sometimes they do change, as you will see shortly. From 26 to the next number, I take away 3 again. So that gives me 23. And again, to get to the next number, I simply subtract 3 again. I just need to follow the pattern on, and that'll give me 20. So these are the next two numbers in that sequence. So the last question in this sequence here will be 245 to 233. Clearly the numbers are going down. By how much? Well, from 38 plus 7 makes 45. So I'm going down by 7. So I subtract 7. From 38 to 31 is also subtract 7. And 31 to 24 is also subtract 7. So my sequence is to simply take away 7 each time. So here 224 take away 7 would give me 217. And I take away 7 again. From that number, I'll end up with 210. So these are the next two numbers in that sequence. Hopefully you got them right. At times you're given a rule and you have to generate a sequence of yourself. So for example, generating a sequence where the first number is 7 and the rule is to count up in steps of 3. So I know what my first number is 7. So I know my sequence will start with 7. And my rule is to go up in steps of 3, counting in steps of 3. So I'm simply adding 3 each time. So 7 plus 3 would give me 10. So that's my second term. 10 plus 3 would give me 13. That's my third term. 13 plus 3 would give me 16. That's my fourth term. And we'll do one more. 16 plus 3 would give me 19. So you simply keep on following the rule and you will get the amount of numbers you need in the sequence depending on the question. Usually they'll ask you for the first 5 terms and so on. Have a go at these questions. Pause the video. You generate the sequence yourself based on the rule that's given. And when you're ready, play the video to see if you get them right. Hopefully you've had a go at these questions. First term in the sequence for the first question is 10, and the rule is to add 6. So I start off my sequence with the number 10. So I know that's my first term, so I can write 10 straight away. The rule is to add 6 each time, so I'm simply adding 6 plus 6 will give me 16. Remember, I'm finding the first 5 terms in these sequences. So I only need to find 5. I found 2 already. To get to the next term, I add 6 again. That'll give me 22. I add 6 one more time. That'll give me 23. Oh, sorry, not 23, it's 28. I'm adding 6, not 1. And then finally add 6 one more time. And that'll give me 34. So these are the first 5 terms of this sequence. Hopefully you got that right. The next question, first term is 5 and the rule is to subtract 3. So I know my first term is 5. I can write that straight away here. Rule is to subtract 3. So 5 take away 3 would give me 2. Carry on the rule. Take away 3 would give me negative 1. Carry it on. Take away 3. Minus 1 take away 3 is negative 4. And carry on one more time. Minus 4 take away 3 is negative 7. So these are the first 5 terms in this sequence. This sequence is going down in steps of 3. Okay, the first term in the next question is 19, and the rule is to subtract 0.5. So again, first term is 19. I can write that down straight away. Rule is to subtract 0.5. You're taking a half away each time. So that will give me 18.5. You subtract 0.5 again. That will give me 18. Subtract 0.5 again. That will give me 17.5. And one more time, subtract 0.5, and you end up with 17. So these are the first 5 terms of this sequence. Question 4. First term is 4, and the rule is to double each term. So double means you times it by 2. So when you double anything, you multiply by 2. So the first term is 4. I can copy that straight away. 4. Now I need to double that. So I need to multiply that by 2, and that will give me 8. Now I need to multiply that by 2. Remember, the rule is to double each term. So I times 8 by 2, I'll end up with 16. I'll multiply 16 by 2, I'll end up with 32. And for the fifth term, I'll multiply 32 by 2, I'll end up with 64. So these are the first 5 terms of this sequence. You're multiplying rather than adding or taking away. And the last question, you have multiple steps in this question. First term is 2, and the rule is to multiply by 3 and then subtract 1. So the first term is 2, I can copy that straight away. Now the rule is to times it by 3 and then subtract 1. So 2 times 3 is 6. 6 take away 1 is 5. So that's my second term. I'll carry on the rule. Multiply by 3, take away 1. Multiply by 3. 5 3s are 15, take away 1 is 14. That's my third term. Carry that on. Multiply by 3, take away 1. Now 14 times 3, 10 times 3 is 30. 4 times 3 is 12. 30 plus 12 is 42. Take away 1 is 41. And finally, one more time, I times it by 3 and take away 1. So 41 times 3. Well, 40 times 3 is 120. 1 times 3 is 3. So 120 plus 3 is 123. Take away 1 is 122. So these are the first 5 terms of this sequence. Hopefully you got these correct. Okay, finally, you might be given a sequence and you have to find the rule. So sometimes you have to find the rule and then you have to carry it on to find the missing sequence like before. So in this case, for example, I've got a sequence of 4, 5, 7, 10, and 14. I need to, let's say if I need to find the 6th or the 7th term, I need to know what the rule is first. Sometimes the rule is very obvious, but sometimes, you have to do some working out to work out what the rule is. Advice is always to find the common difference or the difference from one term to the next term. So from 4 to 5, I'm adding 1. But from 5 to 7, I'm adding 2. And from 7 to 10, I'm adding 3. And from 10 to 14, I'm adding 4. So I can clearly see the rule is this, that from one term to the next term, whatever the difference is, the next difference will be 1 higher than that. So you're adding 1 to the actual difference each term. From term to term, you're adding 1 to the previous difference. So I know from 14 to, if I need to find the next number, the 6th number, I'll have to add plus 4 was from the previous term. So add 1 more to plus 4, I get plus 5. So I need to add 5 to that. So the next term will be 19. And one more time, if I have to find the next term, well, the previous difference was 5. I need to add 1 more to the previous difference, which will be plus 6 this time. And then 19 plus 6 would give me 25. Hopefully that makes sense. So the best way to find a rule is actually to find the difference from sequence to term to term in a sequence, and then you can see what the pattern is, and you can carry on. But be careful. Sometimes you get tempted to think that okay, the difference is add 1 each time, and you only work out a couple of differences, and you think that's the rule, and you carry on. So you'll have a sequence. Have a look at this sequence. Now, seemingly, it's the same difference as the previous question, that you add 1 to the previous difference. So, for example, from 2 to 3, you add 1, and from 3 to 5, you add 2, and so on. So you might think, okay, I know the difference now. So you keep adding 1 more. So next will be add 3, next will be 4 and 5. But be careful. If I look at, for example, the next difference from 5 to 8, it is add 3. It looks, up to this point, it looks the same as the sequence above. But from 8 to 13, it's actually not add 4, because 8 plus 4 is 12 and not 13. So I'm adding 5. So what is happening here? Well, you can see clearly, if you just reflect on it for a minute, you can see that the next number is the sum of the previous number. So for example, if I want to make 3, I'll add, there's nothing here before. Let's start with 5. The 5 is, if I need to add 5, for example, I'm going to add 3 plus the 2 to make 5. So 5 is equal to 2 plus 3. And if I need to make 8, I'm adding the previous 2 terms, which is 5 plus 3. So 8 equals to 5 plus 3. And if I need to make 13, 13 is equal to 8 plus 5, and so on. So actually, this is an example of a very, very famous sequence known as Fibonacci sequence. I believe it's spelled Fibonacci. He was an Italian mathematician who went to North Africa, and he studied with the Arabs of that time. And he's actually very, very well known for his sequence known as a Fibonacci sequence, which can be observed in nature as well. So for extra in-depth knowledge of this, you can actually Google Fibonacci sequence and see what comes up and do some research on that. It's actually very fascinating. Anyway, so the example in this sequence is that to make the next number, you add the previous two terms. So the point was here to make sure that you don't get complacent and thinking, okay, I only need to work out first couple of differences and the rule must be the same as always, but it's not the case. Like I show you the example here of the Fibonacci type sequence. Okay, that's it. That's the examples of sequences. Thank you for watching.